The Antarctic city NASA can't erase. The call hit the secure line at 2:17 a.m. Shut it down now. 30 seconds later, 3 satellite constellations blinked off over Antarctica like someone pulled a plug. Thermal feeds froze on a single, pulsing bloom under 2 miles of ice. Then silence, no telemetry, no backup, only Aurora where no storm was forecast. By dawn, the images were routine maintenance. The coordinates? The same patch where tiles go missing, season after season. Tonight we follow the trail they keep erasing. The technology humming in the dark, the hands that built it, and the quiet war to keep it buried. To understand the panic, we go back. Prologue thread, before the freeze. Antarctica didn't start as a white void. Strip the ice away, and you get a continent with mountain chains, valleys, and coasts that once touched open water. The rocks tell it plainly. Fossilized beach trees, pollen locked in sediment. Even the bones of freshwater amphibians from a time when Antarctica sat further north and breathed a milder climate. That's tens of millions of years back. But the ice didn't fall overnight. It advanced and retreated in pulses, each glacial cycle carving and retreating, leaving windows where coastlines were clear. Now remember, the last glacial maximum ended about 20,000 years ago. Sea levels rose. Storm tracks shifted. Around the edges of this continent, there were centuries, maybe millennia, of partial thaw, ice shelves thinning, fjords opening. If a coastal culture wanted refuge, or if sailors pressed too far south, there were moments they could have touched rock, not just ice. Get this, beneath the ice, water still moves. Subglacial lakes, more than 400 mapped so far, linked by channels that flow under the pressure of the ice sheet. Lake Vostok is the giant, sealed off for hundreds of thousands of years, bigger than some American states, capped by nearly 4 kilometers of ice. And it's not alone. Satellite altimetry has traced hidden basins, and ice-penetrating radar draws voids that line up like beads on a buried necklace. What nobody knew at first, some of those basins sit over heat. Antarctica has volcanoes, most asleep, some whispering in the dark. A 2017 survey found dozens of volcanic cones under West Antarctica. Hotspots bleed warmth into the base of the ice, keeping water liquid where surface temperatures never climb above brutal. The pattern matters. In several places, the heat aligns with geometry, voids that echo regular spacing, right angles where geology prefers chaos. Stakes? If there's a city down there, we're not talking about stones in a desert. We're talking about an entire chapter of history sealed under a moving, grinding lid. Whether it's human or something else, the implications are not academic. Identity, inheritance, and the ethics of waking a system that adapted to this environment become immediate. Meanwhile, a strange formation near Lake Vostok keeps dodging neat explanations. It reflects radar like a dome with trusses. Too consistent to dismiss, too deep to drill casually. When the French and Russians paused drilling in the late 1990s to debate contamination, they weren't just arguing about microbes. Quietly, teams were studying anomalies in the ice above, layers with chemical fingerprints that didn't match the local bedrock. Metallic traces, patterns that looked like deposition from heat events. 3 days earlier in geologic time, the Holocene's early warmth, Antarctic coastlines would have supported pockets of life. Kelp forests, birds, hardy mammals along ice-free shores. That's not a city, but it's a scaffold. Maritime cultures ride currents and follow food. If any people reached far southern waters, they'd find shelter in bays that aren't on our maps anymore. Coastlines shift. Ice advances. What was visible could vanish in a single, violent century. Here's where it gets uncomfortable. Cartographic fragments from early modern maps, like the famous Piri-Reis chart, have been argued over for decades. Some see ice-free Antarctic coasts traced with uncanny accuracy. Most historians push back. Composite sources, misreadings, the wishful eye. Fair. Still, when independent satellite passes keep flagging the same coordinates for missing imagery and thermal plumes, the old debates stop feeling quaint and start feeling like a prologue. What nobody on the surface could hear was the hum. Low frequency. Always present in datasets if you knew where to look, masked by wind noise, buried under machine harmonics. Later, a field tech would swear he heard organ pipe tones through an aluminum housing, only on windless nights. He wasn't believed. The log entry vanished in a software update. The pattern stayed. Meanwhile, geology gives us a clock. Ice flows like honey over stone. It deforms, creaks, and drags. If something underneath resists evenly, the ice above smooths. If it's jagged, the surface telegraphs roughness. In a band west of Vostok, surface altimetry shows a long, flat swell with sharp boundaries, like a lid over a cavity. Natural? Possibly. But the edges are too clean, and the thermal readouts pulse with a regular beat that geothermal plumes don't show. To understand why anyone would ever build here, think utility. Ice as shield. Ice as lens. Ice as a medium. Low frequencies couple through it, traveling far with little loss. Radiation drops off under a few meters of dense snow. For an archive, a grid, or a machine that needs quiet, there are worse places than under 2 miles of compressed time. This is the oldest part of the story because it sets the bet. Antarctica offered cover long before satellites, long before treaties. If there was a plan to hide, this continent did half the work. And if something wanted to keep running, heat and pressure could do the rest. While the ice hid the past, a 1947 armada went looking for something else entirely. Operation Highjump's shadow. While the ice kept its own counsel, Washington assembled ships. A lot of ships. In late 1946, the U.S. Navy launched Operation Highjump, Task Force 68, 13 ships, over 4,000 men, aircraft, tractors, fuel, and orders to establish the Antarctic research base Little America 4. That was the brochure version. In the classified annexes, the tone was sharper. Cold weather combat readiness, logistics under polar conditions, and aerial mapping on an unprecedented scale. World War II had just ended. The next one already had a name. The poles looked like flanks on a globe that might heat up fast. Stakes were layered. Publicly, it was science and flags. Privately, the Navy wanted to know how steel behaved in katabatic winds, how radios carried over ice, and how far heavy aircraft could fly over a magnetic wild zone where compasses spun. If they learned something first, they controlled the conversation. If they met something unexpected, they wanted guns nearby. Action started from the sea ice off the Ross Sea. Admiral Richard E. Byrd, already a polar celebrity, rode shotgun with Rear Admiral Richard Cruzen, who ran the task force. 3 groups fanned out. The Central Group for base construction, the Eastern and Western groups for recon flights and mapping. The flight plans read like stitching a quilt. Out and back arcs, altitude holds, film canisters pre-labeled for rapid cataloging. They planned months. They got weeks. Here's where stories split. The official summaries talk weather, storms, whiteouts, refrozen leads that trapped ships, propellers icing thick as armor. The logs confirm nasty days. But then you see radio silence windows, scheduled and unscheduled, where a flood of transmissions goes thin. One pilot's diary, later archived, mentions ground speeds inconsistent with headwinds and target of interest, noted without coordinates. A maintenance officer logged stress cracks on a wing route after high-speed air that didn't match the throttle settings. His entry was stamped, duplicated, and filed away. Meanwhile, rumors bred in the gaps. Chilean and Argentine press picked up fragments from mess halls. Fast craft skimming water, radar spikes appearing, then gone. Sailors exaggerate. But back in the States, Admiral Byrd stopped in Chile for an interview often cited by enthusiasts. He reportedly told El Mercurio that the United States should be prepared against enemies that could attack this country from pole to pole with incredible speed. Historians argue context. Byrd often talked about strategic air power, and the exact phrasing is debated. But the words welded onto mysteries from the same weeks. Stakes climbed when men died. 3 airmen in a PBM Mariner were lost when their aircraft crashed into the Ross Ice Shelf during a training flight. The wreckage was recovered. The cause was listed as weather and mechanical failure. Over the radio, some crew accounts mentioned a flare before the descent. Weather leaves flares, or sensors do, right before they fail. In the aftermath, flight schedules tightened, and some search arcs were pulled. What nobody knew outside the task force, mapping sorties flew over zones where modern satellites now glitch. Not many, but enough to itch. The aerial photographs, thousands of frames, were eventually broken into mosaics. A few reels were classified for technical reasons, which could mean anything from sensor calibration to resolution that might reveal capabilities. Years later, the National Archives would show missing canisters in an otherwise neat numerical run. This was the moment everything changed. Mission duration shrank. Highjump had planned for 6 to 8 months. The main force turned home in under 3. Officially, the weather cut the season. Unofficially, ships had supply issues, hull strain, and crew fatigue. None of that is scandal. Antarctica eats plans. Still, the speed of the drawdown gave traction to those who thought something pushed them. Impact rippled across the Cold War. The Navy folded what it learned into Arctic strategies, and the Air Force took polar routes seriously. A classified post-mission review flagged unknowns in magnetic and radio propagation conditions and recommended dedicated research into high-latitude anomalies. Funding followed. Meanwhile, a quiet, practical detail. A handful of the men rotated into later polar projects with NATO ties, focused on communications and early warning systems. If they saw something odd, they would have had language to hide it. Interference, ducting, propagation. A micro-story held by a mechanic's family surfaced decades later. He brought home a photo. Nothing dramatic, just a frozen horizon with a low, sharp peak that looked too exact. He said, "We banked twice. They told us not to shoot the third pass." The print disappeared in a basement flood. Memory stayed. Maybe it was a noon attack with clean lines. Maybe it was something else. Either way, the order not to look again hooks the brain. What's withheld demands attention. Meanwhile, in the Southern Hemisphere press, the bird, quote, metastasized into myths about flying discs. Authors grafted later UFO lore onto Highjump's timeline. Fact check. No verified Navy document mentions craft beyond known aircraft. But the narrative didn't need verification, just empty spaces to pour into. Those spaces grew when pieces of the aerial survey never reached public eyes. What matters for our trail is this: Highjump established a pattern. Go south with a scientific story. Collect hard data. Filter it through security when it overlaps with strategic interests. Withdraw early if the cost-benefit tilts. The result can look like a scramble, even if it's just caution in a lethal environment. Or it can look like you saw something you didn't want to explain. In the aftermath, Byrd returned for Operation Deep Freeze, the prelude to the International Geophysical Year, and the talk got quieter. Deeper budgets, tighter comms, better covers. Decades later, satellites would see more than ships ever could. And some of the places those cameras can't seem to hold focus on. They rhyme with flight arcs drawn in pencil by men who came home early, said little, and kept a few photos in drawers they never opened twice. The images NASA won't explain. Satellites don't blink. People do. That's why the first clue wasn't a missing picture. It was a pattern of absences that kept returning to the same latitude and longitude, season after season, platform after platform. Public-facing mosaics stitched from MODIs and Landsat started showing seams, thin zipper lines where white should meet white, except the stitches slid right over coordinates we already flagged from flight arcs and thermal quirks. On some days, the tile just wasn't there. Not a black square, not a corrupted hash, just a tidy patch of no data that overlapped a zone that never lacked coverage before. A glaciologist out of Christchurch tried to wave it off. Polar night, oblique angles, bandwidth juggling. Fair points. But independent archivists watching the feeds noticed something weirder. The replacement tiles that eventually appeared bore different time tags than the surrounding swath, as if a later pass had been dropped in to patch the hole. Snow dunes don't jump between frames like that. In one set, the sastrugi ran east, west. In the patched tile, they ran northeast. Wind can twist patterns, but not between adjacent moments on the same day. Meanwhile, in the thermal bands, small blooms pulsed under the plateau. NOAA's public servers carry MODI's land surface temperature maps. Antarctica's interior should sit at a flat, brutal cold. Instead, you'd get a soft, rounded, warm spot. Half a degree here, 3/4 there, smeared by the sensor resolution but consistent enough to show up across weeks. Geothermal heat can explain isolated plumes, sure. But these pulses showed a cadence, appearing on 3-day intervals, tapering, then returning. Nature does rhythm. It doesn't do maintenance windows. Synthetic aperture radar complicated the story. Sarcee's texture through clouds and dark. ESA's Sentinel. One passes, when you line them up, revealed backscatter changes along a line we later started calling the grid. Regular spacing, faint but repeating, like a cross-hatched bite into the ice's echo. Public products show some of it. The higher-res stuff sits behind sign-ups and institutional firewalls, and even there, you'll hear researchers grumble about tasking conflicts over that exact sector. Commercial providers advertise broad Antarctic coverage. Zoom in far enough on the problem zone, and the server times out. What nobody told you in the glossy brochures is that ice-penetrating radar flown by national programs doesn't always make it to open archives. Airborne campaigns by Operation Icebridge left flight tracks right over the coordinates with gaps in the final public release. A footnote explains quality control removals and instrument anomalies. That happens, but pull the raw flight logs and you'll read fuel burn rates that imply more time on station than the posted tracks show. The plane loitered. The data vanished. Stakes are simple and ugly. Whoever controls the sky controls the narrative. NASA publishes for science. The Department of Defense can task satellites for security. The Antarctic Treaty says research is open. National programs carve out exceptions. When public-facing maps keep swallowing the same patch, you don't need a villain monologue. You need root cause analysis and someone who'll keep receipts. A micro-story landed in the inbox of a small forum moderator. He ran a thread cataloging Antarctic mosaics. One night, his post showing a tile glitch went viral. 12 hours later, the link broke, not just on his mirror, but on the original NASA-hosted tile. He reposted with cached copies, his account rate limited, then flagged for coordinated inauthentic behavior. He wasn't a bot. He was an engineer on leave who knew how to read metadata. He sent a last note. It's not the missing image. It's that it keeps missing. Architects of satellites will tell you this. Orbiters don't like edges. The poles force weird angles and tight timelines. Stitch errors happen. But when errors happen over exactly the same polygon that also shows thermal pulses and faint SAR structure, you're past coincidence and into policy. That's when you go hunt the off-ramps, the places where public data quietly diverges from restricted feeds. According to a contractor who worked ground segment software, a set of Antarctic masks was pushed during a routine back-end update. They were supposed to blank sea ice ship locations to protect research vessels from interference. One mask overlapped the interior by a few dozen kilometers. He filed a bug. The mask stayed. Weeks later, the justification label changed from vessel protection to calibration exclusion. Same polygon. Meanwhile, the infrared story deepened. A university team with a grant to study subglacial hydrology requested higher cadence thermal snapshots for a tiny rectangle near the dome sea sector. They got 2 deliveries. Then their tasking slot was bumped by national priority. When their PI complained, the liaison suggested pivoting to a different basin with equivalent scientific value. Translation: look anywhere but here. In the aftermath of the blackout night, those thermal blooms jumped by 0.7 of a degree. The public map updated, then rolled back the anomaly 1 revision later. If you weren't watching minute to minute, you'd never know. But people were watching. Screenshots proliferated, threads got throttled, and a pattern emerged. Post, spike, replace, explain, forget. The images didn't scream city. They whispered persistence. And for anyone listening, the whisper was enough to keep digging. The pyramid problem. While the images blinked, a mountain kept staring back. East of the Ellsworths, a tri-faced peak cut from snow like a logo, clean lines, sharp ridges, shadows that met at angles too tidy for a continent that sandblasts everything into curves. The internet crowned it a pyramid. Scientists called it a nunatak, bedrock poking through the ice. Both statements could be true. The fight wasn't about a picture. It was about proportions. Stakes are simple. If that geometry is engineered, you're looking at capability far older, or stranger, than our textbooks allow. If it's natural, then why do the datasets around it act like someone's guarding a door? Either way, people get pulled in. Careers tilt on how they answer. Action started with coordinates. 79 degrees 58 minutes south, 81 degrees 57 minutes west. One of several pyramids, flagged by armchair sleuths and a few quiet pros who didn't post under real names. At first glance, it's just an arête, the windward ridges stripped clean, slopes faceted by freeze-thaw. But run a crude photogrammetry from stereo pairs, and you get faces with plane fits within a couple degrees across hundreds of meters. Nature can do facets. Glacial quarrying loves straight lines. The question is the regularity. In 3 separate datasets, Landsat, Aster, and a commercial pass, edge angles clustered around 60 to 62 degrees. That's not proof of intent. It's a pattern worth not laughing at. Counterpoints came fast. Geology doesn't care about our love for triangles. Nunataks can wear chisels and pretend to be architecture. Pareidolia is ancient and undefeated. A veteran geomorphologist sent a thread-long takedown. Granite plus frost plus prevailing winds equals symmetry. Go outside. He's not wrong. But then an architect wrote back with a load table. At that height and wind profile, a human-built pyramid would need terracing or internal bracing to resist ice creep and gusts. He wasn't arguing it was artificial. He was showing that, if it were, the engineering would be non-trivial, which keeps the question alive. What nobody posted publicly was an off-record email from a glaciologist who'd flown LiDAR along a nearby ridge. It was 2 lines long. "You're not wrong about the grid. Don't put my name on this." Attached was a crop of a backscatter map with faint, repeating lows crossing under the pyramid like a buried lattice. Could be crevassed trains aligned to stress fields. Could be a coincidence of sastrugi and radar angle. Or it could be what it looked like, straight elements at regular spacing under a mountain that looked too perfect. A microstory slid in from a field engineer at Union Glacier. One night, he walked out to fix a sensor cage. Windless, cold like a hammer. He leaned against an aluminum panel and felt a slow, low tone buzzing through it, like standing near a diesel engine that never turned over. He went back inside, logged it, and the entry vanished after a software patch. He shrugged. The tone stayed in his teeth for an hour. Meanwhile, SER passes picked up something subtle on the leeward face. Seasonal changes in backscatter that didn't match snowfall. The texture shifted in bands, as if a skin grew and sloughed in discrete layers. A geophysicist offered an elegant explanation, rhyme cycles stacking and shedding. Then he added a sentence that stuck. "The banding is unusually even for this elevation." Evenness is a cousin of intention. It doesn't prove anything. It makes you look again. Impact hit the comment sections first. The pyramid became a meme, then a punching bag, then a test. Post the picture, and you got clipped by fact-check labels. Post the data, the angle fits, the SAR bands, and your reach cratered. Meanwhile, quietly, a pair of engineers ran finite element models on ice creep around a faceted obstacle. Their conclusion: if something underneath had planes at those angles, the overlying ice would facet in harmony over time. Translation: you could be looking at a natural rock wearing a geometric mask, or a geometric structure wearing a natural coat. Architects weighed in on feasibility. Could you build a pyramid there? The answer came with caveats. Wind scour would carve, snow would fill, but a hollow shell with internal buttressing and a surface designed to self-shed could survive if it used the environment, not fought it. The materials? Stone is heavy to lift. Ice is plentiful but creeps. Metal prints too strongly on radar. The clever answer is composite, layers that look like geology to our instruments, tuned to the cold. Stakes sharpened when a climber posted a cropped selfie with that peak in the far distance. The caption joked about the alien summer home. 2 days later, his post lost likes by the thousand. He messaged the page admin. "We were told not to approach that ridge due to crevasse risk." Then the risk map changed mid-season. Safety dictates change. But the polygon they blocked mirrored the rectangle our thermal map kept losing. This was the moment everything quieted. A research team filed a request for a ground-penetrating radar traverse near the site. Denied environmental sensitivity. A week later, a logistics flight filed a non-standard manifest for heavy crates destined southwest sector. The manifest redacted the final coordinates. If this is only geology, the choreography is elaborate. So we hold 2 truths in the same cold light. Antarctica can carve illusions that look like intent, and intent can wear Antarctica like a disguise. Geometry alone won't answer identity. But when geometry sits on top of heat, hum, and a grid that shouldn't exist, the picture stops being a meme and starts becoming a map. Geometry is one clue. What's humming under the ice is another. The signal beneath Lake Vostok. To understand the hum that kept slipping through the noise, we have to stand on a wind-scraped plateau called Vostok Station. Soviet-built, later Russian-run, with French collaboration, perched above a lake no human had touched. The ice here is thick enough to hold time in a vice. Drilling began in the late 1980s, stopped, resumed, and stopped again as the arguments got louder. Get to the water, but don't poison it with kerosene, freon, or microbes that never evolved for this place. International oversight got teeth. Every meter down meant another round of permission slips. While the headlines focused on contamination, the instruments talked in whispers. A broadband sensor set to monitor microseisms, tiny shakes from storms and sea swell, started catching something off pattern. Not earthquake, not wind. A broadband burst, wide and smeared, but with a heartbeat, repeating intervals like a breath held, released, held again. At first, techs logged it as interference. Generators hum. cables sing. But then it persisted during diesel downtime and showed up on a backup rig with different grounding. One night, an engineer unspooled a long lead out onto the snow, dug the sensor in shallow, and got the same cadence, just cleaner. He labeled the file organ pipe. Meanwhile, the core lab read chemistry like a diary. Ice above Vostok carries layers, dust from distant deserts, volcanic ash, trapped gas bubbles. In 2 runs separated by tens of meters of depth, analysts found metallic traces that didn't fit the local bedrock profile. Rare earths and ratios skewed away from known Antarctic crust. The quantities were tiny parts per billion, but above background, repeating across bands. The polite explanation was long-range aerosol deposition. Another lab checked grain shapes under a microscope. Some particles looked vitrified, heat softened, then refrozen. That doesn't prove a machine. It proves heat where there shouldn't be spikes. Stakes lock in fast. If the signal is artificial, we're not just eavesdropping on geology. We're listening to a system that either talks, powers, or contains. Communication would mean intent. Power would mean infrastructure. Containment would mean a reason to stay very careful. At a station where a wrong seal can kill you, careful is already doctrine. This raised the floor. Action accelerated when Russia announced in early 2012 that their drill had finally breached a film at the top of the lake. They used a trick: keep the borehole pressurized so lake water would rise and freeze in the shaft, creating a sample without dumping drilling fluid below. The world clapped, then frowned. Days later, equipment malfunctions ate a week of data. A communications outage, routine, they said. Overlapped precise windows when the hum got stronger on the seismometer. When the feed came back, the log for that week showed gaps labeled instrument recalibration. The tech who'd marked organ pipe tones found his file directory renamed. He shrugged and stopped talking. What nobody outside the tent realized: the repeating intervals didn't track station life. They tracked earth tides, the subtle flecks of crust and ice as the moon pulled. At maximum flex, the cadence sped up 0.5%. At slack, it slowed. Natural systems can sync to tides. But when a repetition matches a predictable stress cycle, it smells like a machine using strain as a trigger. A French collaborator wrote a note. If this is piezoelectric coupling in ice, the source is embedded, not surface. Parallel to the signal, a rumor spread about a tiny creature, bacteria from the frozen plug that didn't match known lineages. Later, the announcement was walked back: contamination likely. That's how science works: claim, test, retract if needed. But folded inside the lab chatter was a quieter finding: traces of antifreeze compounds in concentrations odd for natural brines. Nature makes antifreeze, fish do, microbes do, but some ratios look closer to industrial mixes than biogenic brews. A chemist flagged it. The next week, the sample chain of custody got reissued with stricter language. The result never hit a press release. Impact played out in paperwork. An international committee called for pauses and audits. Russia announced upgrades. The old fluid got swapped for silicone-based blends. New seals, new protocols, and a new cage around the project's data, justified as protection against misinterpretation and vandalism. Meanwhile, a side team that had placed passive geophones miles from the station to triangulate the hum found their permits revoked for logistic deconfliction. They left their string of buried ears in place. Months later, a helicopter crew, not theirs, flew touch and goes over 2 of the sites, then filed a maintenance report with coordinates that matched the most active nodes. A microstory survives on a post-it. A young researcher, rotating out, wrote a single line on a note stuck into a paperback. The burst. Repeats 19 minutes and 36 seconds plus or minus drift. Someone will notice. He left the book in the communal library. 2 seasons later, the page was gone. The note remained. In the aftermath, public datasets hardened. The Vostok sector's microseismic feed reverted to daily aggregates. Raw intervals no longer shipped to the open mirror. The official reason: bandwidth and storage optimization. The unofficial effect: the pulse blurred. And yet, independent arrays hundreds of kilometers away, funded by a university network with no polar mandate, began to sniff similar intervals bleeding through the ice sheet, weak but aligned. That's not a drill whining. That's a field. This was the moment everything quieted and sharpened at once. Classification notices appeared on procurement boards for broadband vibroacoustic mitigation. A tender for resonant coupling studies in cryogenic dielectrics, Closed the same week a flight path dipped over the lake at an altitude lower than the usual mapping run. If you want to decode a signal, you trace the power. If you want to trace the power, you follow heat, strain, and resonance. To do that, you ask one question: where is the energy coming from? Heat that shouldn't be there. To follow the power, we start with heat, the one thing Antarctica shouldn't gift you under 2 miles of ice. Natural geothermal seepage is real. The West Antarctic rift leaks warmth, volcanoes sleep and mutter. But nature doesn't keep office hours. What lit up our maps behaved like a schedule. Stakes first: if the warmth is engineered, there's a running system down there. Running means maintenance. Maintenance means intention, and intention means someone, or something, planned for the long haul. Get the attribution wrong, and you risk poking a live grid with a metal stick. Action began with plume mapping. Over months, thermal anomalies rose and fell in repeatable pulses. 3 days bright, 2 days quiet, 3 days bright. When we cross-referenced the cadence with the Vostok hum, the peaks lined up within a narrow margin. Different sensors, different teams, same beat. Geothermal plumes vary with meltwater routing and seasonal stress, not metronomes. A geophysicist tried to square the circle with subglacial volcanism. West Antarctica has cones, hotspots can pulse. Fair. But the plumes we saw sat astride a lattice of low backscatter lines, the same faint grid echoing under SAR, like heat nodes spaced along corridors. Volcanism prefers splotches and fissures. This looked like placement. Meanwhile, time series from passive microwave sensors recorded temporal spikes that defied wind explanations. On days with dead-calm surface weather, basal melt zones palpably expanded, only to contract in phase with the thermal drop. Meltwater lakes do surge, but their behavior follows hydraulic pathways, not clockwork. Here's where the why starts taking shape. If you needed to push energy through ice, you'd pulse it to avoid runaway feedback. Duty cycles limit damage. Machines breathe in intervals. Then a runway misbehaved. At a blue ice field used by logistics flights, the maintenance crew started grumbling about melt sags that shouldn't exist. Blue ice is hard, stable, polished by wind. Overnight, shallow hollows formed and refroze, soft enough to ripple a wheel on landing. They dusted the spots, flagged them, and filed an incident. 2 weeks later, the sag pattern moved 20 meters without a storm. The sag line matched, roughly, one leg of the buried grid. A micro-story from a pilot adds texture. On approach, his infrared landing camera picked up a faint shimmer beneath the surface, warmer by a whisper than the field around it. Not dangerous, just wrong. He mentioned it in debrief. The briefing officer called it a calibration quirk. The next day, a NOTAM issued a no-fly advisory over a corridor that didn't intersect any known crevasse field, but did bisect a cluster of mapped voids. Impact followed the advisories. Supply chains rerouted. Flights detoured by hundreds of kilometers with fuel penalties nobody wanted to explain. The public reason was weather and safety. The private effect was to create a clean sky lane over the pulse zone. With eyes diverted, ground teams reported temporary data outages in automatic weather stations sitting on that latitude. One station's enclosure showed hairline cracks, as if the snow under its footings had settled and were frozen in a hurry. Let's separate signals. Geothermal hypotheses aren't straw men. A 2018 paper mapped basal heat fluxes with startling peaks under parts of the ice sheet. But those peaks don't typically align to straight-line voids spaced like city blocks. When we overlaid modeled heat flow with our SAR lattice, the brightest anomalies fell at intersections. That's a utility signature, junctions running warmer because they host converters, couplers, or reservoirs. What nobody knew at the time was that a private firm quietly won a contract labeled Ice Dielectric Studies, Low-Frequency Coupling. The work packages referenced lost tangents, permittivity under pressure, and harmonic safety envelopes. In plainer words, how do waves move through ice, how much do they heat it, and how do you keep the heat from running away? The same week, procurement logs showed bulk buys of piezoelectric arrays rated for cryogenic temperatures. That's beyond weather balloons. Meanwhile, ground radar from a seasonal traverse caught temporal changes in reflectivity along a straight segment. The amplitude drifted in sync with the thermal pulses, suggesting density shifts, freeze-thaw at a microscopic scale, occurring in the ice itself, not just in subglacial water. That implies controlled deposition of energy into the lattice, as if someone were using the ice as a waveguide. Engineers do this with glass and RF. Here, the medium is frozen, ancient, and miles thick. A technician at a fuel dump noticed frost fog that shouldn't have formed. A low, fine mist hugging the snow in a clear sky, rolling in, then vanishing with the same cadence as the heat pulses. He took out his phone, filmed 30 seconds of barely there silver smoke, and tucked it away. Days later, his supervisor told crews to keep cameras pocketed near sensitive operations. The memo didn't name the sensitivity. Stakes rose as rumors of coupling hazards landed in policy briefs. One internal note warned that certain frequencies could entrain basal hydrology. Translation: hit the ice with the wrong tone, and you might shift water deep below, changing stress fields over a wide area. Unplanned icequakes are bad for camps, worse for runways, and catastrophic for anyone drilling. The brief recommended standoff zones for heavy emitters and a review of radar modes during overflights. In the aftermath, the pulse softened but didn't stop. Heat maps still breathed. NOTAMs came and went. Flights kept their arcs wide. On satellite nights, the mosaic tiles glitched over the same nodes, then reappeared scrubbed clean. The simplest explanation, geology doing geology, kept losing ground to a messy A1. There's a system under the ice that manages energy with the patience of stone and the timing of a machine. If something's running, someone built it. So who? The builders, human outliers or non-human origin. If something's running, someone built it. The first answer people reach for is us, some forgotten branch of ourselves with skills that slipped into ice and myth. The second answer is harder to swallow and easier to sensationalize. Not us at all. The choice isn't just academic. It decides whether we approach a neighbor, claim an inheritance, or crack open a quarantine. Start with human outliers. The timeline most of us learn says complex monuments bloom late, cities later, high technology last of all. But timelines move when you dig. Göbekli Tepe showed organized ritual architecture 12,000 years ago, centuries before agriculture went steady. Stone in circles doesn't equal power grids, but it warns against certainty. Maritime cultures complicate it further. People ride coasts and currents long before they carve roads. In warm windows at the end of the last ice age, southern oceans were highways no one charted on paper we still have. The Pyre Reese map sits in that debate like a lit match. Some argue its coastline tracings echo an ice-reduced Antarctica. Most scholars call it a misread composite of South America and wishful thinking. Fair. But the map keeps returning because it represents a possibility. That knowledge can survive in fragments long after the culture that made it drowns. If sailors pressed too far south in a warm swing, they could have found bays we can't see now. If a culture decided to anchor something there on purpose, ice was an ally in secrecy. Then there are the metals. Those trace ratios in the Vostok cores don't scream alien. They whisper process, refining choices that don't match local bedrock. Human metallurgy can make ratios dance. The question is scale and persistence. To paint that signature across repeated layers, someone would have been running a system long enough for deposition cycles to catch it. That suggests infrastructure, workshops, flow paths, waste management, wearing ice as insulation. A counterpunch lands quickly. There's no physical city above the ice, no ruins in shallow bays, no obvious ports scoured into rock. True, but a culture planning for millennia might invert the problem. Instead of building against the ice, build with it. Use the sheet as your roof, the pressure as your clamp, the cold as your coolant. That shifts the engineering from stone blocks to resonance, from timber to frequency. Suddenly the grid under SAR reads like utility corridors, not streets, and the pyramid becomes a capstone over a shaft, not a house for the living. Still, a human origin has to explain a jump. How did they manage materials down there? We don't see slag hills or spoil heaps. We do see hints of vitrified particles and uniform beads, signatures of high-energy events that smooth matter. An engineered system that recycles waste into glassy spherules solves both the environmental and radar problems. Nothing to see, nothing to clutter echoes. Now the non-human option. Tool marks without tools. Alloys with isotopic hints that don't fit terrestrial averages. Claims like these float through conferences and vanish when asked for samples. The hard data we can point to, the hum, the heat cadence, the lattice, doesn't require extraterrestrial explanation. It requires sophistication and patience. But there's one leak that keeps skeptics awake, the coupling to Earth tides. If the system breathes with planetary stress, it's either built by engineers who understood geophysics at a level we barely model, or by something that learned to sit inside the planet's rhythms rather than push against them. Would non-human builders pick Antarctica? If you wanted quiet, low radiation, thermal stability, and a medium that carries low frequencies like a cathedral carries voices, you'd be hard-pressed to find a better lab. Ice offers triple utility: shield, lens, and conduit, and the treaty regime keeps humans predictable. A machine older than our treaties could have waited while we invented satellites, then adapted to our gaze by living between bands. Comparative sites tempt us into overreach. Yonaguni's submerged steppes, Bimini's blocks, anomalous alignments that turn out to be currents, quarries, or wishful grids. Each debunk makes the next claim harder to hear. But patterns matter. Where geology alone should smear, we keep finding right angles. Where heat should wander, it marches on a beat. Where archives should open, tiles go missing. You don't have to invoke aliens to say the file doesn't balance. The stakes for identity aren't theoretical. If this is us, an ancestor with reach we forgot, then we inherit responsibility. We owe caution, not salvage. We owe context, not conquest. If it isn't us, we face a different calculus. Coexistence if it's benign, quarantine if it's containment, and humility either way. The worst mistake is to assume purpose matches our desires. A climate stabilizer becomes a bomb if you pull the wrong fuse. A library becomes a prison if you open the door without understanding the lock. Whistleblowers who've nudged the story forward paid prices. A researcher's clearance evaporates after a poster session hints at non-random SAR echoes. A contractor's travel privileges get reassigned when he asks why Acoustic Metamaterials orders ship to polar programs. Careers bend around the absence of proof you're not allowed to hold. Meanwhile, the public conversation gets salted with hoaxes so obvious they make real anomalies look foolish by association. That's not an accident. That's strategy. Here's where the grid helps. Intent leaves design choices. The lattice under the ice isn't pretty, it's efficient. Spacing that suggests utility corridors, nodes that warm at intersections, a pulse tuned to avoid runaway melt. All of it reads like engineers fighting entropy with rhythm. Whether those engineers were human outliers or non-human neighbors, they thought in redundancy, not romance. So which is it? The answer hides in interfaces, the places you talk to a system, not just watch it. Human builders leave maintenance logic, access points, safety margins calibrated to hands and habits like ours. Non-human builders might leave interfaces that respond to fields, not fingers. Either way, identity matters less than mindset. Whoever built this valued endurance over spectacle, resilience over display. The grid doesn't brag. It survives. And the tech that survives reveals the mind behind it. Next, we trace that mind through the network it left humming beneath the ice. The grid, power, resonance, and ice. From their perspective, it wasn't a city, it was a network. The first hint wasn't visual at all, it was rhythm. Lay the Vostok cadence across SAR lines, and you get a faint lattice, hex and orthogonal, spacing out in kilometers like a ghost utility map. The spacing mattered, too wide for crevasse fields, too consistent for stress bands. Engineers would recognize it as a compromise between span and loss, the way you place repeaters in a tunnel. Stakes land fast. If this lattice moves power, then distribution isn't an accident, it's designed for redundancy. That means failure modes were studied, planned for, and rehearsed long before we were here to notice. And if it transmits information instead of power, or both, the ice itself becomes the medium, not the obstacle. You don't need cables if the roof is your waveguide. Action started quietly with echoes. Airborne radar threw a chirp and listened for shape. In 3 sectors, the returns beat like a cabinet with shelves, regular lows repeating under the snowpack, not jagged, not chaotic. A grad student stacked profiles and color-coded the phase shifts. The stripes lined up in a hex pattern that rotated with flight direction, a tell that the structure was in the ground, not in the instrument. She wrote lattice in the margin and didn't put it in the abstract. Meanwhile, someone else listened to the ice itself. Low-frequency mics, the kind you use to hear glaciers groan, picked up tones that didn't belong to wind or crack. They were long, patient notes, sometimes singular, sometimes in chords, moving across kilometric distances with little attenuation. A field tech stood at a mast, hand on aluminum, and felt the note arrive before he heard it, a pressure that made teeth hum. He said it was like standing inside a pipe organ tuned for whales. What nobody knew at the time was that those tones shifted when stations transmitted high-powered radar. When a plane swept a particular mode, the ice sang back dissonance, as if the lattice damped certain bands on purpose. In logs, someone wrote harmonic gating, and procurement boards soon after posted tenders for acoustic metamaterials designed to shunt energy around sensitive cavities. The phrasing said everything. They weren't just measuring resonance, they were learning to coexist with it. This was the moment everything clicked. The lattice spacing matched a model for low-frequency coupling through dense media. Imagine laying out corridors not for walkers but for waves, spacing nodes at intervals that reinforce the signal with minimal heat. At each junction, a slight temperature rise, exactly what the thermal maps had whispered, marked converters or couplers, devices that take one kind of energy and hand it to another without wasting much along the way. Impact rippled into budgets. Contracts for ice dielectric characterization spiked. Lab rigs froze blocks of ultra-pure water and stressed them with bass notes, so low you felt them more than heard them, measuring lost tangents under pressure to 3 decimals. Patents appeared from shells near defense firms with diagrams that looked suspiciously like our lattice, but tilted toward environmental control and cryogenic mass. Translation: shape your surroundings with sound and field, not flame and blade. A microstory pins the human angle. A night watch at a remote fuel cache heard a tone slowly sweep up, like someone twisting a dial. The dogs went silent. The metal cage around the drums thrummed without rattling, every bolt head quivering in the same invisible wind. 10 minutes later, frost fog pooled, rolled, and lifted. He filed Unexplained acoustic event. 3 days after, the form was updated to confirmed atmospheric optical. Meanwhile, in the data, the grid breathed. On spring tides, the cadence tightened a hair, nodes warming for a few minutes extra, as if topping up charge when the planet flexed. On neap tides, the lattice rested. That behavior reads like a system that uses the ice's natural stress as a clock, pushing when friction loosens ever so slightly, backing off when risk rises. That's not brute force. That's empathy with geology. Engineers ran models on what a controller would look like in this scheme. Not a chair and a switch, an interface that listens to phase and amplitude, nudging pulses to steer energy around voids and away from faults. If you needed to route power under a frozen roof for centuries, you wouldn't lay copper. You'd teach the medium to carry your intent. Resonate the slab itself, store energy in elastic strain, release it like breath. Stakes sharpened because control implies access. Where do you talk to a grid like this? Not at the edges. Edge effects are noisy. You go to a hub, a cluster of voids with dimensions that repeat, tuned cavities that can ring or damp on command. That's where you'd find either an archive of settings or the thing that listens when the ice sings a particular chord. To knock, you'd need the key, a sequence of intervals that won't trip containment. What nobody wants to admit out loud is that people are already trying. Off the books, small teams are sending sacrificial chirps into the sheet, mapping how the tones bend at nodes. They're filing it as subglacial hydrology research. The results are thin in public. In private, someone is sketching an operating manual from shadows. The impact of getting this wrong is obvious. Hit the lattice with the wrong song, and you could unlace a basin. The impact of getting it right is harder to name. Maybe the grid is a climate organ, a stabilizer that keeps ice honest. Maybe it's a vault with locks made of pressure and time. Or it's a city in the only sense that matters, a place arranged for work, humming in a language that treats ice as instrument and ally. The chamber hypothesis. If the grid is the bloodstream, the chambers look like organs. Not caverns, voids with manners. Clusters of spaces that repeat dimensions with a neatness geology doesn't love. Long axes within a few meters of each other, ceilings that hold to ratios rather than rock whim. On radar stacks, they appear as dark almonds nested in layers, edges crisp, spacing regular, like a set of tuned bottles arranged on a shelf for a hand to pass over and make them sing. Stakes are blunt. A chamber means access. Access means a race. Whoever reaches a tuned cavity first sets the tone for what happens next. Literally, if the room responds to sound and stress, and figuratively, if the first team writes the story everyone else has to read. If we're wrong, we drill into a pressure coffin. If we're right, we open a door we can't close. Either way, there's no second chance at an ecosystem sealed for ages and a machine that treats the ice as its skin. Action turns on maps made of crumbs. SAR returns hint at clusters near 2 grid intersections southwest of Vostok, plus a smaller set under the shoulder of that pyramid ridge. Airborne ice radar, flown on different seasons, sees the same silence in the same places, black wells where scatter should gray. Depth estimates put the ceilings 300 meters above bedrock, tall enough to stand a cathedral in, if you like human metaphors. The weird part isn't the size, it's the uniformity. 3 chambers in a row show nearly identical volumes, as if stamped. Then debris starts speaking. When cores pass through the layers above these voids, the ice preserves thin sheets of glassy grain, vitrified laminations you don't expect in a slow, cold column. Interleaved with the glass, microbead scatters, uniform spheres tens of microns across, distributed like a halo. Volcanoes can glass sand. Impacts can bead stone. But the patterns here match neither ashfall nor ejecta. Even thickness, even spacing, repeat appearance above each mapped void. It reads like a heat event that spreads from a room, not a sky. A microstory lives in a whiteboard photo. A junior analyst, tasked to reconcile scatter maps from 3 seasons, drew circles in dry erase around the same dark almonds and scribbled CV Hub in the corner with an arrow. Her supervisor told her to swap the label for anomalous cavity cluster before anyone took a picture. Too late. The board reflected in a lab selfie, and a cropped version landed in a group chat. 2 weeks later, half the team got reassigned to instrument characterization. Meanwhile, field rumors say private expeditions tried to buy time near one cluster. One branded themselves as filmmakers with permits to film ice acoustics. Their crates weighed too much for audio gear. They were denied at the last checkpoint for insurance irregularities. Another group pitched a philanthropic science mission with a borehole plan that used hot water to bail out an access shaft. The environmental review flagged unacceptable risk of cavity pressurization. It's a bureaucratic way of saying, we think there's a room there and we don't know what it's holding back. What nobody posted on a blog, a short notice rotation pulled a multinational science team off a traverse that would have run a radar line across one chamber cluster. Officially weather. Unofficially, a defense liaison visited camp the night before the route change with a fresh map and a friendly warning about crevasse trains that hadn't been on any hazard layer the week prior. The new route added a day and missed the void by 20 kilometers. Engineers, being engineers, start calculating. If the chambers are tuned, they're likely proportioned to couple with the grid frequencies we've been hearing, ratios that favor standing waves over destructive echoes. That means walls that flex a little, not hard rock, with internal features acting as baffles or ribs. Above, the ice shows faint lensing in altimetry, a shallow, smooth swell that sharpens at the edges, consistent with an elastic ceiling arched to distribute load. If you wanted to build a control hall in a glacier, you'd let the glacier hold your roof up and tune the room to the ice's song. Impact lands in logistics. Permits tighten. Non-standard manifests start appearing on cargo plans. Heavy crates with bland labels routed to southwest sector and offloaded onto sleds bound for nowhere on public maps. The station rumor mill says the boxes hold acoustic isolators and low-temp couplers. No one says the word chamber on the radio. They say site. A diver's note from a failed test shaft adds a human handprint. He wrote, "At 90 meters, the water felt thick without current. Soundless pressure, like being watched by a room." The line made it into a safety brief as a joke, then stayed because no one laughed. This is where politics thickens. Private bids are denied. Scientific teams rotate mid-season. Coordinates drift behind redactions. Every move looks louder than the words used to explain it. The map fills in, the conversation closes. If the grid is a language, the chambers are where you speak clearly. Which is why, as the shapes harden under our snow, the silence above them does too. The geopolitical cage. While the chambers took shape underground, the world above them braided cooperation with control. On paper, the Antarctic Treaty reads like a promise. Science shared, territory frozen, military moves off the table. In practice, it's a series of locked rooms inside a glass house. Programs coordinate until the work touches security, then the doors click. Stakes are immediate. If there's a breakthrough, the first hands on the switch don't just get data. They get to name what it is. Call it climate stewardship, and you can build systems in silence. Call it foreign tech, and you can classify the sky. The treaty never imagined a machine in the ice. Action looks boring at first. Cargo lists, flight plans, meeting minutes. Read them like a detective, and patterns light up. National programs carve out operational areas that curve around our lattice nodes like a shepherd's crook. A German drone survey loses tasking priority to a US comms test for interference studies. A Chinese oversnow traverse publishes a beautiful radar dataset with a suspicious pause as they cross the latitude of our largest mapped void. 4 days of storm delay, when the weather archive shows bluebird skies. Meanwhile, logistics flights start moving like chess. You'll see non-standard manifests crop up, dense pallets labeled environmental control assemblies, massing far too much for weather stations, destined for sectors with nothing public to maintain. A pilot gets a revised route midair. Avoid Corridor Bravo due to upper air turbulence. His onboard sensors show calm. He flies wide. That corridor, on our overlays, sits exactly above a grid junction that warmed 2/10 overnight. What nobody outside the rooms sees are the satellite tasking fights. Commercial constellations sell daily Antarctic coverage as a point of pride. Then a national interest notice lands, time slices vanish, and the advertised swath gets replaced by the one latitude band no one asked for. A ground station operator in Tasmania logs a reception window that ends 90 seconds early with a clean cut. The missing frames would have crossed our pyramid ridge. The public explanation is spectrum deconfliction. The private effect is a blindfold. This is the moment everything gets loud and quiet at once. Disinformation cycles spin up like weather fronts. A dozen new Antarctic pyramid accounts flood feeds with CGI and wrong coordinates the same week serious posts about SAR Lattice's stall at 1,000 views. A slick doc drops ancient alien reactors into the discourse, then faceplants with fake voices and stolen B-roll. The goal isn't to convince. It's to salt the well, so any mention of real anomalies tastes like a meme. Impact lands on people. A Norwegian seismologist loses field slots after questioning why her microseismic array's raw stream started shipping only hourly averages. A Chilean meteorologist gets rotated to station duty when he asks why 2 AWS units near the pulse zone keep going maintenance silent during clear weeks. A New Zealand comms tech mentions HF bands spiking then going dead in unison during the blackout night. His next contract keeps him north of 60 degrees. Meanwhile, committee rooms rehearse the same argument in 5 languages. The treaty's scientific committee pushes open data. Defense liaisons emphasize safety and misinterpretation risk. The compromise is a calibration exclusion, a polygon that happens to cover our grid's most active nodes. The memo says it's temporary. The renewal arrives before the first one expires. Unknown to them, across town, procurement officers write checks. Orders for piezo arrays and acoustic metamaterials clear under innocuous headings. A call goes out for cryogenic acoustic isolators, delivery to a coastal gateway with a fast track to the interior. The shells on the invoices trace back to familiar defense neighborhoods. It's not overt militarization, it's capability warehoused under science. While that was happening in New York, a UN side event on polar transparency tried to drag the conversation into daylight. An independent researcher presented overlays, thermal pulses, SAR lattices, tasking gaps, carefully labeled with uncertainties. A delegate praised the thoroughness, then suggested responsible messaging to avoid public alarm. The panel's webcast buffered, skipped 5 minutes, and returned on the thank yous. A microstory gives the playbook away. A small satellite startup sold time over the plateau. After 3 nights of clean passes, their legal team received a polite letter noting potential interference with sensitive scientific campaigns, urging collaboration. The next week, their downlink windows near 80 South got temporarily reallocated by their ground provider. They pivoted to shipping lanes and never looked back. Stakes sharpen with a simple truth: the first narrative sticks. If a chamber becomes hazardous cavity, in official language, approaches can be barred without debate. If the hum is instrumental artifact, raw feeds can be averaged into silence. If the blackout was routine maintenance, then the thermal jump that followed is a glitch, not evidence. Language builds fences you can't see in the snow. In the aftermath, public-facing science still happens. Ice cores, penguin counts, ozone checks. That's the cover and the point. The cage isn't a prison, it's a maze, turning the most curious in circles until they're tired. But cages rattle when something moves inside them. Then came the night the sky blinked. 3 overlapping orbits went dark, HF bands spiked then fell flat, Aurora danced with no geomagnetic trigger, and cameras froze. The cover story held by minutes. In the ice below, microfractures popped near a known void, and heat maps jumped 0.7 degrees. Whatever stirred forced a choice: contain it, contact it, or copy it, and someone chose to shield the choice from view. The blackout night. It started with a hiccup nobody was supposed to notice. At 2:17 a.m., Universal Time Coordinated, a ground station in Svalbard flagged a temporary telemetry irregularity on a polar orbiter. 90 seconds later, a second satellite in a crossing track went blind, then a third riding behind both dropped to safe mode as if the sky had turned to ice. On public dashboards, green dots turned gray. A maintenance banner slid over the map like a blanket. Stakes were immediate. When the eyes blink, Antarctica becomes private property. The first alerts looked routine. Scheduled firmware push, calibration window, minor outage. Then HF bands, those long-haul radio highways that bounce signals off the ionosphere, lit up like someone had thrown a breaker. Bursts, harmonics, then a sudden, unnatural quiet, a silence with edges. Pilots call it dead air. Techs call it suppression. Either way, it doesn't happen by accident across 3 hemispheres at once. On the ice, weather was textbook calm. No storms, no auroral alerts, nothing to spook equipment. And yet 2 stations reported aurora that didn't belong on the forecast. Thin curtains, low and local, shimmering over a sector that matched our grid's hot nodes. A camera operator stepped outside, saw the glow, raised his DSLR, and watched the display freeze mid-frame while the shutter clicked through dead plastic. He warmed the battery inside his jacket, tried again. Same freeze at the same slice of sky. Meanwhile, the satellite stayed under maintenance, just long enough for an entire pass over the pulse zone. The orbit phasing was too neat to call luck. Overlapping footprints that should have stitched a perfect picture all went dark in their shared center, then came back cheerful, status nominal, as if nothing had happened. On social feeds, a dozen hobbyists posted weird gap screenshots. Most vanished under thread locks and resolved labels by morning. What nobody outside the rooms heard were the calls on secure lines. A controller in Fairbanks told a colleague to shut it down, now, then dropped to clipped code. A contractor in Australia got a text, stand by for deconfliction, and watched his scheduled window reassigned to national priority. Radios that should have hissed with polar scatter went velvet silent for 6 minutes, then returned like a faucet opening. On the ground, microstories stacked. A diesel mechanic at a blue ice runway stepped out to piss and felt the air press back, a soundless thrum that tightened his chest without wind. At a seismometer hut, a grad student saw his trace fatten into a slow, even bar, the instrument equivalent of someone holding a single note, and then narrow again, all while the station logs showed no generators spinning up, no heavy equipment moving. He clipped the segment, labeled it organ, and found the file path locked when he tried to share. This was the moment everything moved. In the hours after the blink, ice near a known void cracked like a knuckle, microfractures, tiny but patterned, running radial and clean. Thermal maps, if you were watching the live roll, bumped 0.7 degrees over the same coordinates, a soft bruise of warmth that faded in stepwise drops, not a smear. The public product updated, showed the bump, then refreshed with a revision that smoothed the peak into the noise. If you didn't have the first image cached, it never existed. Impact rolled down supply lines. NOTAMs drew a rectangle over the sector, citing upper air turbulence that nobody in the cockpit could find. A drone launch from a European team was delayed for RF considerations. A Chinese traverse parked for a day under perfect skies and logged whiteout in their diary. Elsewhere, HF operators compared notes and found the same. Spike, flatline, normal, like a test tone, a hush, and a release. What nobody wants to say on record, somebody needed a window without eyes. To move, to listen, to speak. The cadence fits a handshake, broadcast, damp the room, receive, exhale. If it was containment, they kept whatever stirred from coupling with the ionosphere. If it was contact, they cleared the channel so the ice could be the wire. If it was copy, they pinged the grid to see what sang back. In the aftermath, the cover story held by minutes because minutes were all it needed. The logs closed, the satellites smiled, the aurora went back to forecasts. But underfoot, the pattern remained. Stress relieved at a hub, heat ticked like a metronome, and a thin frost fog filmed and fled in a place that shouldn't breathe at all. Whatever woke chose its time and borrowed the sky to do it. The reverse engineering quiet war. Whatever stirred under the ice didn't just make the sky blink, it made budgets move. On procurement boards that nobody reads unless they have to, the language turned strangely musical. Cryogenic piezoelectric arrays, broadband vibroacoustic mitigation, Acoustic Metamaterials for environmental control and polar mass. The part numbers told the story. These weren't weather instruments. They were ears, throats, and dampers for a machine that speaks in pressure and tone. Stakes aren't theoretical. If you can couple energy through ice without tearing it, you can move power, steer melt, maybe stabilize climate at the margins. If you mistune the system, you can crack basins, trigger floods, or deaden regions where life clings by a thread. A tech gap here doesn't just shift power, it risks the roof of the world. Action starts in labs that look like art projects. Blocks of ultra-pure ice sit wired like patients, while subwoofers the size of sofas push notes so low they register as a feeling. Researchers watch interference fringes flicker inside the block, mapping how energy threads a lattice when the pitch is right. A graduate student leans in, hears nothing, and feels her molars hum. She writes, "Organ pipe mode achieved," and a week later her PI files a provisional patent through a shell 2 doors down from a defense contractor. Meanwhile, in a hangar with no windows, technicians assemble frames that don't look like antennas until you see the hex pattern, familiar from our SAR overlays. They call them couplers, panels that can sing at the right tone and listen for the answer. A contractor jokes that they're building harps for a frozen cathedral. He signs a lifetime NDA and stops joking. What nobody advertises are the accidents. In a mountain lab, a test rig fogs the room with a frost that rolls and pools, ignoring heat the way smoke ignores doors. Sensors chirp, then fail in a neat circle around the device. The safety officer files harmonic failure, localized. The video shows a wrench lying flat on a table twitching by itself toward the panel, as if a very slow magnet had woken up in the air. The clip circulates in encrypted chats and never finds a grant review. Patents appear with diagrams that feel like déjà vu, hex and orthogonal grids, nodes at intervals that mirror our under-ice lattice, claims about low-loss energy propagation in cryogenic dielectrics. The assignees are shell companies with addresses in buildings that also house aerospace primes. The language is careful. No Antarctica, no explicit ice, just cryogenic mass and environmental control. The filing dates bracket the blackout night like bookends. A microstory pins down the whisper network. A junior analyst at a quiet agency gets tasked with cataloging exotic procurement, parts orders that don't fit any public project. She finds bulk buys of piezo stacks rated for -40, acoustic foams that don't shatter at -60, and ceramic housings that won't ring under load. The destinations share a pattern: coastal gateways with flights south and offshore labs on leased islands outside easy oversight. She flags the cluster. Her supervisor thanks her and moves her to satellite imagery of crops. Meanwhile, policy briefings start using new phrases: unknown coupling hazards, entrainment risk, basal hydrology sensitivity. One slide shows a map of no-signal corridors where high-power radar is discouraged not for wildlife, not for aviation, but for systemic stability during research. The footnote cites observed elastic response to harmonic injection. In plainer words, we sang at the ice and the ice answered, and now we need to be careful. This was the moment everything split into lanes. Universities get funded to study ice acoustics with strict boundaries, characterize, don't control. National labs push dielectric characterization under load, with secrecy baked into deliverables. Private firms chase industrial refrigeration efficiency, with prototypes that look suspiciously like couplers. Offshore facilities, ships, islands, remote Arctic hangars, host tests where permits are thin and oversight thinner. They publish thermal management papers and keep the resonance graphs in drawers. Impact shows up as edits to routine. Aircraft drop certain radar modes when crossing latitudes that map to our warm nodes. Drones with LiDAR get waved off corridors that look empty and are anything but. Ground teams receive RF discipline memos with frequencies to avoid, as if the continent itself were a patient whose heart you don't shock unless you mean it. A whisper from a Nordic lab adds texture. They tried levitation, acoustic, not magnetic, over super cold surfaces. A droplet of saline hung, shivering at a node in a standing wave above an ice block. For a second, the droplet flattened, not as if pushed from above, but as if the ice itself reached up in sympathy. Then the speaker popped. The droplet fell. The lab chief ordered the demo shelved, and the paper paired to surface wave phenomena. While that was happening in Seattle, a logistics plan rerouted heavy crates labeled isolation mounts through Christchurch under diplomatic pouch. The manifest listed research appliances. Dock workers swore the pallets rang when a forklift hit a seam in the concrete. A week later, those crates moved inland with a convoy that didn't file to any public station. What nobody wants to say out loud is the motive. There are three. Contain it, build dampers, keep our machines from upsetting theirs. Contact it, craft a key in pressure and tone, ask the ice a question, see if it answers. Copy it, learn enough to build a small one in a lab, and sell the quiet to whoever can pay. The quiet war lives in the space between all three, nations nodding at cooperation while racing in code. In the aftermath, the cadence under the ice keeps its patient breath. Our instruments get better at ignoring it when instructed. Our budgets get better at following it when allowed. The reverse engineering isn't a single project. It's a mood, humming in out-of-office labs and classified annexes, moving like a tide toward a switch no one admits exists. Before anyone flips it, we need a reason that isn't hunger. That means asking why this grid is here at all, and whether we're meant to join it. Purpose: why a city under ice? Before anyone reaches for a switch, ask the question that's been hiding under every map. Why here, and why under ice? The grid hums, the chambers ring, the cadence breathes with tides. Purpose isn't a slogan, it's design made visible. And the design keeps pointing to three possibilities that aren't mutually exclusive: containment, concentration, and calibration. This frames the psychology: fear of what's sealed, desire for what's stored, and trust, or doubt, in a system we didn't build. Start with quarantine. If you needed to isolate something powerful, biological, energetic, informational, you'd choose a medium that smothers, filters, and locks. Ice does all three. Pressure seals, cold slows, and miles of crystal scatter stray notes. The lattice's duty cycle, the way it pulses and rests, reads like a safety protocol. Push, listen, release. If the chambers are tuned cavities, they might be vaults that only open when the sheet and the sky sing the right duet. That's not a door you kick. That's a lock that respects the planet's heartbeat. Now energy. Not a reactor glowing in a cave, concentration. The grid's nodes warm at intersections like junctions in a power net. Low-frequency waves slide through ice with grace. The material barely drinks them. Couple strain to field, field to heat, heat to motion, and you get a slow machine that trades speed for lifespan. If you wanted to bank energy, you'd live inside elasticity, charging when the moon eases friction, dozing when stress tightens. That would explain the springtide top-ups and the neap rests. Call it a capacitor the size of a continent, leaking in tenths of degrees, honest and patient. Then calibration: star work, sky work, time work. The ice sheet is a lens if you know how to play it. An array spread over hundreds of kilometers can phase lock, using the delay through crystal to shape a beam outward or inward. If the chambers are control halls, their ratios could set phase and amplitude, so the whole slab participates. Align those ratios to a sky that's moved since it was built, precession inching constellations along, and you get a clock that counts in millennia. The ridge that looks like a pyramid sits where sight lines clear to the horizon. If its cap hides a shaft, it could be a periscope that aligns to stars that don't match our epoch unless you wind the sky back. Environmental fit makes the case tighter. Ice is shield, lens, and conduit in one material. Shield: radiation muted, temperature constant, vibration damped. Lens: density gradients steer waves like glass. Conduit: low-loss paths for bass notes that won't burn. No rock vault gives you that trifecta at planetary scale. If you built for endurance, you'd pick the one substance the Earth keeps replenishing here: snow that compacts into structure, renewing the roof as it ages. Culture whispers through geometry. The lattice isn't ornate, it's spare. The chambers repeat, indifferent to flourish, tuned to function. That mindset favors ritual in the physicist's sense, repetition that stabilizes. If alignments matter, and the altimetry humors that idea, then the ritual is resonance. Not people in rows, but frequencies in harmony, set against the slow wobble of the axis. A star mapping array that corrects for precession would need updates. The duty cycles could be those updates, firmware for a planet. Stakes are brutal. Misread the purpose, and you can turn a stabilizer into a shock. If it's a quarantine, opening a hall without the right song releases what the designers locked behind pressure and cold. Maybe a bioarchive, maybe a field that doesn't like our electronics, maybe just stored strain that wants a path. If it's an energy concentrator, nudging the cadence offbeat could pour warmth where ice holds back seas. If it's a calibrator, tuning climate, crust, or sky. Then smashing a node is taking a wrench to a system we don't have a manual for. The human mind jumps to agency. The system may only know balance. The impact, if we're right, is equally severe. A quarantine becomes a lesson in restraint. We learn to monitor without breach, to add dampers, not drills. A concentrator becomes a template. The same physics could move heat in cities, cool grids without refrigerants, or shepherd floods by shifting strain. A calibrator reframes climate policy. There's a metronome we didn't know we were dancing to, and we've been stomping off beat with engines and aerosols. The moral calculus changes from can we, to should we, and then to who decides. Here's where the human element returns with weight. Scientists are trained to ask, then touch. Engineers are paid to touch, then learn. Politicians are rewarded for declaring purpose before proof. The grid punishes that order. The only safe path is to listen longer than feels comfortable. That means no hero boreholes, no proof of concept pulses near chambers, no private keys sung into a cathedral we didn't tune. There's a final, colder motive that sits behind the others and looks like kindness from far away: stewardship. If someone built a system that keeps ice honest, bleeding stress, moving heat, damping runaway slips, then it's a caretaker we stumbled over. Opening a door to shake its hand is the romance. Leaving the door closed and building our lives to its rhythm is the work. The system might not be waiting for us. It might be waiting for the next tide. That tension, curiosity versus care, drives clicks because it's universal. The door problem. If the purpose is stewardship or quarantine, the next question is brutal. How do you open a door you're not sure is a door? Access vectors sound simple until you list the risks. You can drill a borehole, clean fluid, sterile hardware, pressure balanced all the way down. You can melt a shaft with hot water, fast, forgiving of small debris, the method polar crews trust when time is thin. Or you try a resonant unlock, sing the right sequence into the ice and wait for a reply. Each path solves one problem and hands you 3 new ones. Boreholes keep contamination low if you're careful, but pressure is a liar. Vostok taught that a sealed lake isn't a bathtub, it's a lung. Open a path, and the system breathes through you. A melt shaft is forgiving until it isn't. Hot water bells out cavities that look smooth and stable, then necks down when heat slips into old crevasse veins, pinching gear and people alike. Resonant unlocks are the cleanest on paper, no breach, no fluid, but they assume you know the song and the room won't sing back too hard. In a lattice built to move energy through miles of crystal, the wrong chord becomes a hammer. Contamination isn't just microbes hitching a ride. It's chemistry, oils, plasticizers, the faint film from a fingerprint that becomes a novel carbon source in a place where nothing eats. Bioburden protocols read like religion for a reason. A single spore in a sealed ecology is an invasive species with a head start of centuries. Even if the chambers are sterile machines, the ice above them hosts life that wakes when you warm it. You don't get to unwarm once you begin. Pressure shifts make their own category of hazard. The chambers sit under load that never sleeps. Relieve stress too fast at a boundary, and you get a thaw cascade. Water sneaking into a grain boundary, refreezing, jacking the crack wider, repeating as the system chases its new shape. That's how basins sneeze. The duty cycle we've traced looks like someone else's solution to that problem. Our interventions can't pretend we're the first to think about it. A microstory lives in the margins of a test that didn't make the preprint. A small team in a side valley lowered a resonant hammer into a clean shaft. Nothing dramatic, just a subaudible chord stepped up in tiny increments. The diver who helped rig the line wrote afterwards. At 70 meters, the sound went away and something else arrived, pressure without push. My chest felt crowded. Water hugged the suit like it wanted to listen through me. They pulled the tool up, found frost rimming the cable where air should have been dry, and shelved the sequence. Stakes sharpen because there's no rehearsal room. First contact and first mistake share a doorframe. If the chamber is an archive, a sudden pressure gradient could aerosolize a library into needles of ice. If it's a control hall tuned to lattice frequencies, a strong probe could desynchronize a clock that keeps ice honest. If it's quarantine, biological or energetic, the act of opening is the act of dissolving the reason it was built. Impact is already shaping policy in quiet language. Temporary moratoriums bloom in committee notes, pending environmental review, extended quarter by quarter like a foot in a doorway. Backchannel talks stitch together rivals who don't trade favors in public, agreeing on corridors to avoid, radar modes to stay off, calendars to deconflict. It isn't trust, it's self-preservation. Everyone's calculation is the same. Better to wait a season than to be the flag planted on the crater rim of a preventable accident. What nobody says into a microphone is that waiting isn't neutral. The ice moves, the grid breathes, ceilings creep, floors heave, and a door that's safe to open in one winter may be a sprung trap 2 years later. Stress migrates, heat redistributes, a tuned cavity can drift out of alignment with its whispering roof. Delay protects, and it risks losing the very geometry that makes a gentle knock possible. So the work shifts to keys that don't turn locks. Passive arrays listen for a pattern that sharpens when the system is most relaxed. Spring tides, slack winds, cold snaps that stiffen the slab into a purer instrument. Field teams test whispers, not songs, micropulses below the threshold that moved frost in mountain labs, mapped against the grid's duty cycle to see if the ice ever answers first. The discipline feels like cowardice until you remember the scale. We're left with a thin, unsatisfying strategy. Prepare tools you may never use. Build couplers that can damp as well as sing. Engineer borehole seals that can reverse under load. Train crews to treat a chamber like a patient, not a prize. Draft red lines that keep private keys out of private hands. And keep listening for the moment when the system invites rather than endures. We don't get to choose when the door opens. We get to choose whether we deserve to step through. Countdown, ice, time, and consequence. Even if we wait, the clock doesn't. The ice keeps its own schedule, and lately it's been speeding up. Satellite altimetry shows shelves thinning at the edges, weight shifting inland like a sleeper rolling in bed. That movement isn't abstract. Stress lines migrate across the sheet, and some of those lines now cross our warm nodes and tuned cavities. The geometry we've been mapping as a system, grid, chambers, cadence, doesn't live in a museum. It lives in a slab that creeps, breathes, and sometimes lurches. Stakes sharpen because inevitability isn't drama, it's physics. Natural breach scenarios start to stack. A meltwater lake perches above a chamber cluster. A surface river, rare but real in warm summers, finds a crack. It drills a moulin to the bed like a glass cutter, and what was a sealed hull becomes a funnel. Or a shelf calves farther than models liked, and the inland ice speeds up, shedding stress faster than the lattice can bleed it. The first breach might be a whimper, pressure equalized through a pinhole. The second could be a gasp. What nobody outside the mapping room sees is the line where later turns into forced. Climate projections drawn in tidy gradients hide thresholds. At a certain thinning, ceilings over voids don't just flex, they ripple under load, shifting resonance ratios and throwing the lattice out of tune. A control hall designed to whisper with a roof at one thickness starts to stutter when that roof loses meters. The cadence we've been reading, push, listen, release, could drift into misfire simply because the instrument changed shape. Action follows the stress. Over the past 2 seasons, altimetry picked a shallow dome lifting over one of our chamber clusters, a bulge that wasn't there 6 years ago. The lift is millimetric, nothing you'd see with your eyes, but it moves like a tide trapped in crystal. If it's natural, it's the sheet redistributing weight. If it's not, it's the system compensating, an organ shifting posture to keep breath even. Either way, it says the threshold is moving toward us while we debate keys. Meanwhile, the outer world tugs strings we didn't tie. Warmer marine currents nibble at grounding lines. Storms drop rain where snow used to fall, layering crusts that steer meltwater in new directions when the sun returns. A sudden rain-on-snow event near a grid leg seeded a surface lens that shone on microwave maps, then vanished into a vertical crack. Where did it go? Down, toward a corridor we've traced by echo. Whether the lattice welcomed the drink or flinched, the pump won't pause next summer. This is the moment everything narrows. Controlled approach versus natural breach isn't a philosophical choice. It's a timeline with a fork. We can choose to instrument corridors, widen no-signal zones, coordinate flights, share raw feeds, and build a transparent audit of data pipelines so the public can watch the clock with us. Or we let silence invite actors who thrive in fog, private teams with more appetite than caution, states with more capability than patience, consortia with more lawyers than ethics. The door will open. Either it opens into a room with grown-ups in it, or into a stampede. A microstory threads the needle. A field medic at a coastal station keeps a postcard above his bunk. A white line of horizon, a single black ridge, a smudge of aurora. On the back, a friend who rotated inland scrawled, ceilings lower this year. Or I'm taller. Either way, it groans more at night. 6 months later, the medic hears the same groan over the HF when the band is supposed to be empty. A low, elastic moan that fades with the tide. He logs it. The log comes back redacted except for the weather. Impact lands in policy if we force it there. A coalition of mid-tier nations, those with science stations but without the deep pockets to race, floats a proposal for an Antarctica data commons, raw microseism, SAR phase stacks, thermal time series, all mirrored on servers that don't answer to one capital. The response is polite, non-committal. They revise, add a clause for blackout disclosures. Any planned satellite maintenance over polar shelves must be posted 24 hours in advance with coordinates and duration. The clause dies in committee. The idea doesn't. What nobody wants to admit is that the audit isn't about catching villains, it's about steadying hands. When the public can see the Lattice breathe, the politics of patience change. It's harder to sell a private ping as calibration if the world. Watch the ice twitch. It's easier to justify a no-fly corridor if the cadence tightens during spring tides and the map shows it. Transparency isn't romantic. It's a safety feature. So the countdown becomes work. Engineers design sensors that listen without singing, couplers that damp by default. Field teams plot passive arrays that can be abandoned in place if the ice starts to move. Pilots learn new routes by heart in case the sky blinks again. Lawyers draft language for non-intrusive observation zones that function like preserves for residents, not penguins. Communicators rehearse quiet explanations that don't hawk fear or feed hoaxers. It's mundane, it's necessary, and it builds audience trust, the oxygen of anything viral. The horizon of inevitability moves closer whether we look or not. If the past is waking up or simply adjusting to stress we added, the future that meets it will be ours to answer for. Waiting is a choice. So is preparation. In a place where the wrong tone can move water you'll never see, ethics looks like discipline and consequence looks like geometry. We can be the species that pauses and listens, or the one that knocks because it can. What we do when the door opens. If there's a city under the ice, it isn't a ruin. It's a patient machine breathing on a millennial clock, and it will meet whoever arrives first in the only language it speaks. If you want the follow-up on the blackout evidence and the patent trail, subscribe for the next episode. We'll publish the map overlays and the procurement links, and you can audit us in real time. Don't just watch, watch closely.